Alright, so yesterday in class we did an activity where you all did a foldable on air masses and one on fronts. In this video we're going to review those two concepts. While you're listening to the video, be sure that you have taken notes on it if you didn't do so already, and that you're paying attention, as at the end of the video there will be a few questions for you to answer to see how well you understand the two concepts of air masses and fronts. So to start this video off, we need to define an air mass. Air masses can be defined as an immense body of air that's characterized by similar temperatures and similar amounts of moisture at any given altitude. So anywhere throughout that air mass, at any latitude, it's going to have very similar temperatures and have a very similar moisture content. Air masses do move, and they will be moving from areas of higher pressure to areas of low pressure. When an air mass moves out of a region that it formed in, it's going to carry those same temperatures and moisture conditions. So that means as it moves, the characteristics of an air mass are going to change, and so does the weather in the area in which the air mass moved. So, for instance, if you had a very cold air mass, such as this one here up in Canada, this one is very cold. As it moves, the temperatures over the area that it's going to move over are going to become cooler. And the same thing here. You have a maritime polar air mass that formed over water. It's near the equator. As it moves northward, it's going to bring very warm and moist air along with it, and it's going to affect the weather in those regions. Air masses can be classified, and we classify them based on their temperature and the surface area over which they formed. So, for instance, this air mass here is a continental polar air mass. It's continental because it formed over land, and it's polar because it formed at a higher altitude far away from the equator. Those that form near the equator are tropical air masses, and they're going to be warmer than air masses that form farther away from the equator, which are polar air masses. So with that being said, polar air masses polar air masses are going to be those with cooler temperatures that form at high latitudes far away from the equator near the poles. Tropical air masses are going to be those with warm temperatures and they form at lower latitudes near the equator. Continental air masses are going to form over land or continents. And maritime air masses are going to form over water. So, tropical air masses are humid and moist. Polar are cold and dry. And maritime always form over water, and continental always form over land. Based on those different formation areas, we can classify air masses into four basic types. The first one being continental polar, which would be a air mass that formed over land far away from the equator, so near the poles. It's going to be cool and dry, and it's going to bring cold and dry winters and summers. Then we have a continental tropical air mass, which is a dry, warm air mass. It's dry because it formed over land, and it's tropical. I'm sorry, it's warm because it is tropical. That means it formed at a low latitude near the equator. So a land mass where this one could have formed over would be somewhere near the equator, such as Mexico, and any other land mass near there. Then we have the maritime tropical air mass. Maritime meaning it formed over water, so it's going to be wet. And tropical meaning that it formed at a low latitude, so near the equator, meaning that it's going to be warm. This type of air mass can bring a lot of precipitation to the United States. An example of a location that a maritime tropical air mass could form would be near the Gulf of Mexico or over the Gulf of Mexico. And then finally, we have the maritime polar air mass, which is wet and cold. Wet because it formed over water, and cold because it's polar and it formed at high latitudes far away from the equator. And then we can see that weather patterns in North America are mainly influenced by either continental polar air masses or maritime tropical air masses. So most of our weather systems are going to be influenced by those. So when these air masses are moving, they can meet, and the area where they meet along is known as a front. So a front is the boundary that separates two different air masses, and fronts form when two air masses meet. So we have four main types of fronts that we're going to discuss. The first one is a warm front. Here you see the symbol for a warm front, which is the red semicircle. So a warm front forms when warm air moves into an area that was formerly covered by cooler air. What happens here is the warm air glides up over the warm air glides up over the cold air because the warm air is less dense, so it's going to rise, and the cool air is more dense or has a higher density, so it's going to sink. This type of front will bring light to moderate rain when we're looking at weather conditions. And then we have the cold front, and you see the weather map symbol for the cold front here, which is a blue triangle or blue triangles. Cold fronts form when a cold air mass moves into an area that was occupied by warmer air. And what happens here is the cold air is very dense. It's going to force itself underneath the warm air, and this is going to cause for lots of thunderstorms to develop. And here's a diagram showing you that. The third type of front is a stationary front, which is created when cold and warm air masses meet, but neither of them has enough force to move the other one out of the way. The airflow on this type of front is going to be parallel to the front. Um, the water vapor in the warm air is going to condense and it can form either rain, fog, snow, or clouds. And it can bring many days of precipitation because the front's not moving anywhere because it is a stationary front. And then finally, you have an occluded front. An occluded front will form when a warm air mass is caught between two cooler air masses. The two cooler air masses cut off the warm front from the ground, or the warm air mass from the ground, and then that warm air mass is going to rise or be forced upward by those two cooler air masses, and they can turn cloudy, rainy, or snowy. And here's a diagram showing you that. As you can see, you had a cold air mass, and right behind it, a warm air mass came in, but another cold air mass advanced behind that warm air mass, causing for it to be forced upward, getting a lot of cloud development from that warm, moist air. So here you have a question. That question reads, a high pressure system is moving to the southeast as shown on the weather map. Cold air is usually found north and west of a high pressure system. Warm air is to the south and east of the front. Based on this information, what is the best prediction for weather on the day after the system passes the point marked X? So here you see your point marked X. And your answer choices are A, you have wet air with cooler conditions. B, dry air with cooler temperatures. C, wet air with warmer temperatures. Or D, drier air with warmer temperatures. You can go ahead and eliminate C and D, because we know that it's a cold front. So we can say that, excuse me, we can say that we know it's not going to be either of those because we see the word warmer in those two answer choices. So you should have chosen B, so you're going to have drier air with cooler temperatures. And here is just a weather map showing you some of the different types of fronts, or all of the different types of fronts. See how many different types of frontal systems you can identify in this map.